Hello and welcome to the Residential Certification course. I'm Jerry Winslet along with Mike Dial. And in this course we're going to be talking about tools of the trade. Now contractors always ask what type of tools should they carry on their truck when they go out on service calls. These are the tools that they must carry in order to go out on service calls and accurately diagnose those problems with gas and electric residential water heaters. One of the most important tools that you can carry on your truck is the multimeter. Gas and electric water heater, residential water heaters, use some form of electricity. And with a multimeter, you can accurately diagnose those issues. But they make many different multimeters. Let's talk about some of the different types and which one that we recommend.
They do. They going to vary in price range depending on their functionality or their ruggedness. So what we have here, and this is the multimeter we would actually recommend. This is an auto ranging multimeter. This is the UEI Phoenix G2, and because it's auto ranging, it takes a lot of the guesswork out. So if you're not familiar with working with a lot of electricity, as long as you know what test you need to perform, you can set that, and it will determine the range for you.
Okay.
Another type of multimeter, this is going to be a manual ranging, so we're actually going to have to set the range, so we may have to know a little bit more about what we're testing. Right. But what we're going to do, and you can see we've got all these different ranges here, so we've got volts and amps and the different things, so we need to know what test we're doing and specifically what range that we would be looking for. So this one does require a little more knowledge about what you're testing, whereas the auto ranging, that we would recommend.
This will actually do it for you.
It does.
One of the most important things, though, with choosing the right kind of multimeter, you'll need one that does measure millivolts DC, because with gas water heaters, we will be having to do some tests that require you to measure millivolts. And speaking of tests, let's talk about some of the different types of tests that you can do with the multimeter.
Typically with a water heater test, whether it's gas or electric, we may be checking for voltage, we may be checking for ohms, for continuity, or like you said, millivolts DC.
Okay. One test you can do with a multimeter is to measure ohms.
That's right, Jerry. And ohms is the upside down horseshoe symbol here, and we're just going to we'll put our meter there, and this one, of course, auto ranging, it's going to determine what range we need to be. And ohms is a measure of resistance against the electricity. And when we pass electricity through something that has resistance, heat is created. So we have electric elements, we have hot surface igniters that are going to be both gas and electric water heaters that we might have to do this test.
Okay.
So when we're testing for ohms, the important thing is, one, the power has to be off. And we have to disconnect whatever component so that we isolate that component and we're testing just that component. So when we test an element, for example, now this is a 240 volt, 4,500 watt element, and different heaters may use different elements. So the test is going to be the same, but the value may be a little bit different. But for this one, we would expect to see between 12 and 13, around 13 ohms resistance. So if you'll hold that for me, I'll get this set up. So again, with the power off, that way we don't have to worry about getting shocked. We're going to disconnect the wires, and that way we're just testing this element, and we don't have a chance of maybe testing anything else feeding back through. So we've got it set for ohms, and right now it says OL, or open line, meaning that there's no resistance, there's no path for electricity to follow. And we test each of these screws here, and again with the wires off and the power off, and you can see we're coming up at 13.5 ohms, which is the range that we want to see. So if we were to pass electricity through this, with that type of resistance, would generate heat, and that's what heats the water. Okay. Another test that we can do using the ohm setting or measuring for resistance, it's going to be for like a hot surface igniter, and this is going to be used on our power vent gas water heaters, some of our gas water heaters. And the test is really the same. We isolate the two wires that are coming from the igniter. So this plug actually has 3 wires. It's got another connection here, and it's typically going to be on the 1 and 2 for most of our water heaters. But again, follow the wires back from the igniter itself, and we're just going to test in between those 2 connections. So I'm going to put one port in here. I'm going to put another oh, good. All right, and then we're going to see that we have the resistance. That way when we pass the electricity through there, this hot surface igniter will get hot enough to glow, and it's going to light the gases and allow the water heater to heat.
Another test you can do on a multimeter is to test voltage. Now, both gas and electric water heaters use some form of electricity, so having this multimeter is going to be very handy for that.
It will. When we're testing volts, we're going to set to the V section there, and we see that it's got a couple of different things. It's got a little red squiggly line. It's got a solid black line. So this is something even on an auto-ranging multimeter, we still may have to know exactly what voltage we're checking. So the AC voltage, which is what we're set up for right now, we've got a squiggly line there on our display. This is going to be your household voltage. So this is going to be the power that normally comes into the water heater. DC voltage, if we hit that select button, we're going to change. There's going to be a solid line and 3 dashed lines underneath of it. So this is going to be voltage that might be generated by a battery, or it's going to be used in an electronic control system. So knowing the right voltage that we want to check, one of the things that we may check for voltage with is going to be for power coming to an electric water heater. So here at the upper thermostat, we would check here at these top 2 connections to see if the voltage is there. Now, it's important to keep in mind, in order to check voltage, we have to have voltage on there. So there is a possibility that you may get shocked. So we want to take every step that we can to avoid that. And one of the things is that all of the leads on the meters, now these are a little bit smaller than some of the other ones but they have finger stops. And you should keep your fingers behind these stops. And that way there's no chance of you getting accidentally shocked. So something else that we might check, now this is going to be where we would switch it again over into the DC volts, would be a thermocouple. And this is going to be used on some gas water heaters, and this is what a thermocouple looks like. And as this tip is heated, it generates 10 to 30 millivolts DC, which is not a whole lot of power, but it does generate power, and there's a chemical reaction. That's why it says AC volts. And so to test that, what we're going to use is we're going to use some jumper wires with alligator clips, or some of the multimeters may come with the alligator clip that will screw onto the leads. And we're going to test one connection here to the silver connection there at the tip, and the other just anywhere along that copper. So with the flame present, we should see at least 10 millivolts DC. We may see more, but 10 to 30 is a good range, but we have to see at least 10 or we don't have enough power to operate the gas valve. Now, a thermal pile is like a bunch of thermocouples that are put together. There's about 30 thermocouples that are in a thermal pile, so it generates a little more voltage. In this one, we're looking for at least 350 volts, and that's going to energize and provide power to some of our gas valves that have onboard diagnostics. So the test is very similar. With flame here on the tip of this, we're going to generate some power. Now, our thermal piles have some connections there that have a door on there. And this one we want to test while it's connected to the gas valve, and that way we get an accurate test because the gas valve is going to be using some of that power. So with our meter set for our volts and with the pilot running, we would test in between these 2 connections. At least 350 millivolts is required to provide enough enough electricity for the gas valve to operate.
Now, there are some precautions that you might need to take if you're dealing, I know we're talking about residential gas and electric around 240 volts, but we may be dealing with higher voltage as well. I mean, there may be some precautions that they may have to take.
Absolutely. Once we get above the typical range that we might see when we get into 480 and greater volts, we do need to make sure that you're wearing the right personal protective equipment. So face shields, heavy gloves, things, because those higher voltages more likely to be able to shock you, and they're very dangerous.
Another test you can do with a multimeter is to test continuity on a circuit or on a switch.
That's right, Jerry. Continuity, and when we test that, we're going to turn it here to, it's a speaker with sound waves coming out of it. It also kind of looks like a Wi-Fi symbol. And what we're doing is, again, we're measuring ohms, and you can see it's showing open line, but we're looking for a very small value. Which is going to guarantee that we can pass electricity from one section to another. So like a switch that we would turn lights off on, that's interrupting the power and then reconnecting the power. So when we have it set for this, we're going to get an audible tone anytime we can pass electricity between those 2 points. All right, so one test that we may use continuity for would be a pressure switch on some of our power vent water heaters. Now this pressure switch is a normally open pressure switch, meaning that there's no continuity between, there should be no continuity between these leads. And when the fan comes on, it moves and closes that switch just like a finger would on a light switch. So when we test this between these 2 points, and just like with ohms, we're going to do this with the power off and with it disconnected, and you see that there's no tone, so there's no continuity. And if the fan comes on, we would expect then for that change to come in, and then we would see a tone. which lets us know that the switch is closing and allowing power to go through.
And those are on our power vent water heaters.
Those are on our power vent water heaters.
Okay.
Okay. This is something else that would be on a power vent water heater, and this is a flue temperature switch.
Okay.
So to make sure that our flue temperatures aren't too hot where we could damage the venting. Now this should be a normally closed switch, so when it's cool, we would expect there to be continuity through this. And we're just going to test in between these two connections here. And you can see we've got a continuity, we've got our tone. That means that power can pass from one side to the other and allows the water heater to operate.
These are safety devices, aren't they?
These are safety devices to make sure that everything is come on and doing what it's supposed to do so that the water heater doesn't operate in an unsafe condition.
Okay.
One more test that we might do, and a lot of our water heaters have what we call door switches on there, which are monitoring the temperature inside of the combustion chamber, and if it gets too hot, it would prevent power from going to the gas valve and operating. So that door switch, when we remove the front cover, we would disconnect the wires and we would check for continuity between those 2 points. And we would expect to see continuity. If we don't, then we would find out what caused that to get too worn.
And the last test we're going to talk about using a multimeter for would be measuring amps.
That's right, Jerry. When we're measuring amps, we're measuring the amount of electricity that's flowing. So this meter does it with this setting, but different meters are going to have different settings, and it may have an A symbol on there for the amp. And this is a clamp-on meter. So what we're going to do to measure, say for an element to see if it's working, we're going to clamp this around just one of the wires. Now there's 2 wires going to the element. It's important that you only get 1 wire. And if everything is working correctly, we'll see the amps being represented here. For traditional water heater, standard water heater, it's using a 4,500 watt element. We would expect to see about 18 amps, give or take just a little bit depending on the power. If we do see that we have the amp draw there, we're measuring amps, that means that the thermostat is closed, the element has continuity and resistance, and everything is working like it's supposed to.
Another tool that's very important for a contractor to have is a manometer. Now we use manometers on gas appliances, blowers, and we use it for to test gas pressure as well.
That's right, Jerry. And a manometer is good to use. We could use just a pressure gauge, but a manometer is going to give us more accurate readings. And it's important with the manometer, and they'll normally come with some fittings, a range of fittings that we're going to use to connect the manometer to our gas system, either whether it's the supply piping or manifold on the gas valve or to connect to our blower ports.
Now we're looking at a UEI EM151. Now this is a digital manometer. I know they have different types of manometers, or they have slack tube, but it's important for us to have a digital manometer because we're reading tenths of inches of water column.
We are, and so this one you can see that we can go through the scale and we can measure a couple of different values and PSI would be something that would be like tires in your car, but we're measuring inches of water column, which is it's a smaller measurement than 1 PSI.
Okay.
There's about 14 PSI in a half a pound or 1/2 of a PSI, so about 28 in a full PSI, and we are dealing down to the 1/10 of an inch, so having a digital manometer allows us to get those accurate readings.
Okay, and some of the different uses for the manometer would be, let's talk about, air pressure, or in our case, we'd be dealing with like a blower on a power vent water heater.
All right, so a power vent water heater does use a blower, and the blower is going to pull the air and gas products up through the heater and then help to exhaust those out. So that blower has to generate some type of pressure to activate a pressure switch, and that's how the heater knows that it's working. So on the discharge or the intake of the blower, depending on the model, there's going to be a port that would be connected to our pressure switch with a hose a lot like this one. And so what we would do is disconnect the pressure switch hose and then connect our manometer hose. Now, once we have everything connected and the heater's not running, it's important that we zero the manometer out. And so most manometers will have a zero button or a tare button that will take us, and it will just set it to a zero pressure. And that way we know that we're reading accurately. Then we would get the blower to come on, and then we could see exactly how much pressure is being generated.
Yeah, and then we would take that and look at the pressure switch and see if the value, if the pressure switch is actually working or not working at that point.
Correct. Something else that we would check would be gas pressures. And when we're testing gas pressures, probably the most important is going to be our inlet gas pressure.
Okay.
So this is the amount of pressure that's being supplied to the heater, and we actually test this 2 different ways. One is our static pressure. Now that's with the heater not in operation.
Okay.
So that's just how much gas pressure is being pushed up to the heater. Now The dynamic pressure is going to be with the heater in operation. So we should see a pressure drop, a slight one. So we want to see less than 1.5 inches of pressure drop, and that's going to help us know that we are getting the right volume of gas. So each heater has a minimum and maximum pressure. We want to make sure that we're inside of that range when we're in the static pressure with the heater not running. And then when we operate the heater, we want to make sure that that pressure drop, one, that it doesn't fall outside of that range, and two, that it doesn't exceed our static pressure by more than 1.5 inches.
And while we're doing that dynamic pressure test, that we need to make sure that we have all gas appliances, anything that uses gas, running while we're doing the actual test.
That's right, Jerry, because we want to make sure that the water heater always has enough gas. So during the summer months, the water heater may be running, but maybe a furnace or something wouldn't. Where in the winter month, when more appliances are using that gas, that could cause a problem with the water heater. So like you said, make sure that everything that uses gas is running when we do that dynamic pressure test.
Now that's supply pressure. You're talking about supply pressure. Now there's also manifold pressure, which is a little bit different, right?
That's right. So manifold pressure is the pressure that's leaving the gas valve. And so that's going to be a little bit lower than our supply pressure coming into the gas valve. And this is making sure that we have the right amount of gas going into the heater so that the heater can operate properly and heat the water the way that it's supposed to.
Okay. Another tool is a combustion analyzer. Now, although we don't use these on residential water heaters, you might have one on your truck if you work on commercial water heaters.
That's right, Jerry. So these are not used on residential water heaters because everything is fixed and nothing is adjustable. So as long as you have the right amount of gas and you've got your venting installed correctly, there's no adjustments and everything is ready to go. There's no adjustments to be made. But on some of our bigger commercial models, we will get in and we'll use this. And what this does is this really, what we're looking for is a relationship between oxygen and carbon dioxide.
Okay.
And so when combustion takes place, that's going to affect those. And as one goes down, the other one will go up. And this is allowing us to make sure that we're burning at the proper mixture of air and fuel. So to use a combustion analyzer, we've got a probe, and this is connected with a cord. It's actually a tube, and there's a small pump inside of our combustion analyzer that's going to draw flue gases. So we'll need to drill a hole into our flue, and then we've got a stop here. And we want to make sure that we set this stop for about half of the distance of what the vent diameter is, because we want to sample the flue gases that are in the middle of the vent where there's no restriction, and that gives us the best mix. So we'll make that adjustment, and then we'll begin our combustion analysis. And what that does is that gives us these values, and we know the values because of the type of equipment, and that's going to be in the manuals and our service handbooks. We know exactly what that needs to be, and we can make the adjustments either to the air or to the fuel in that case to make sure that we have good combustion.
So it's just measuring what it's burning clean or not.
Right.
Okay. All right, some of the other tools that you need to carry on your truck would be some open-end wrenches. You're also going to need like needle nose pliers, but there's also some specialty tools that you're going to need to carry. Let's say, for instance, an element wrench. That's something that they'll probably need to carry on their truck.
Yeah, especially anytime you're working on an electric water heater and you need to remove the elements either for inspection or for replacement because they've gone bad. Now this is an element wrench that you can get at your local hardware store, and it's just stamped, and it does okay. But the first time that you encounter a stubborn element, it's going to round this out,
Right.
and that's going to be the end of that. So this is good for one or two, just a few uses. What would be better,
something like this. This is actually designed for elements. This is a socket, but there's a difference between this and an automotive socket, isn't there?
right, now so this is an 1.5 inch socket, and this is the one specifically for elements. This is for an automotive socket, and this automotive socket has got bevels. With an element, there's a very small face that we can grab onto, so these bevels may allow this wrench to slip on the element, make it more difficult, where this one, the bevel's been removed, so we can get flush on there and get a good grip on the element and allow that to come out pretty easily. And this is going to last you for quite a number of years, if not for your whole career.
Right. Another thing you'll need a tool for is taking out an anode drive.
That's right, an anode rod. An anode rod uses an 1" 16" socket. And this, it's okay to use an automotive socket because the anode head has got a large face on it. We've got plenty to grab onto. So just a standard automotive 1" 1/16" socket will help you quite a bit. Now, anodes can get seized in there pretty well. They can be difficult to remove. So the best practice would be to use something like an electric impact, a cordless electric impact. And that's going to allow you to get that anode out a lot more easily than if you have to do it the old way. You can use a breaker bar, and you may need to have a cheater with that, some elbow grease to get that thing loose.
And somebody to hold the water heater.
Absolutely, you need somebody to hold the water heater because of the amount of force that you're going to put on this, we could twist the water heater. So making sure that it's secure.
Now, you may be doing installations and you might need different tools for that. Always consult your owner's manual.